Our new lesson is comparing different units of rate, rate of change, and slope. Those three terms can be used interchangeably. Their definitions are slightly different, but overall their value is going to be the same whenever we calculate it. So these are all generally the same. They just have a slightly different definition on what specific detail you're looking at. For rate of change, if you think about rate of change, that's like thinking about how much things cost per unit or per dollar. So the rate of change for purchasing something like gas, we do gallons, dollars per gallon. Whenever you buy a piece of candy, it's dollars per candy or cents per candy. Whenever you are driving a car, your speed is a rate of change, miles per hour. In other countries, it's kilometers per hour. A unit rate is just whenever we find out how much it is for one, okay? And slope is talking about the change of the value compared to the other change of the value, okay? And we'll talk about that a little more in depth. The definitions for this, for rate of change, it's the percent of change in value over a defined period of time. In other words, a lot of the time whenever we talk about rate of change, we say something per something else, like miles per hour, words per minute, dollars per hour. For unit rate, a rate for one of something. So what it is taking that rate of change and simplifying it so that the denominator is 1. So if I tell you that I worked 5 hours and I made $20, what's my unit rate? How much did I make for each hour? You would just take that $20 and divide it by 5, and you would find that I made $4 an hour. $4 an hour is the unit rate. The rate of change is the money per hour. In that case, I said 20 per hour, or 20 per 5. Slope is talking about rise over run on a graph. Okay, the change in y compared to the change in x. And we're talking about on a coordinate plane, the x and y axis. So we draw a coordinate plane, and we'll just talk about the positive quadrant 1. All right, so let's say we do okay, so I just wrote cookies per packages. So if we're talking about the rate of change. It's however many cookies per however many packages. So we could say that there are 9 cookies per 3 packages. Okay, but if I wanted to reduce it down to a unit rate, how many cookies are in one package? 3. And you can see that on the graph. There's 3 per 1. Now let's say it wasn't counting by ones here, and it was showing you six cookies for 2 packages. You would just divide 6 divided by 2 to find out the unit rate. All right, and now let's talk about slope. Slope is the change in y over the change in x. Now, the y-axis is the vertical axis. The x-axis is the horizontal one. That's always going to be true. How much is the y value changing from the start of the graph to the first point? How far up? From the origin to here, how far is that? 3. So the change in y is actually 3. And then we take it and compare it to the change in x. How much is x changing? How far over? We went up 3 and then over 1. So it's 3 over 1. And that happens to be our unit rate. Our unit rate is 3 per package. Even if we did the change in y, let's say from the origin to that second point, it's up 6 over 2. What's 6 divided by 2 though? 3. And that's still going to be our slope. And our slope is going to be that reduced amount. It's equal to the unit rate. And so this one's up 3 over 1. And the next one, from this point to the next point, it's up 3 over 1. And then from this point to the next point is up 3 over 1. And let's say that you were looking at it a little differently and you saw, well, I go over 1, up 3. Well, the change in y is still 3 and the change of x is still 1. It's still the same thing. You just still put them in that same order. A slope having, or a unit rate or a constant rate of change, they always have a straight line. They cause a straight line. All right, looking at our examples, and I'm sorry about these graphs. These graphs were just supposed to be picture examples above the problem. I forgot to move them and they're in the problem, so just ignore them. We're talking about like words per minute, profit per box of cookies. That's just giving you examples of what you might be looking at. For number 1, Rimmer can type 260 words in 5 minutes. So how many words can she type in 7 minutes? Well, a rate of change is 260 per 5. So how do I find out my unit rate? Divide. So take 260 divided by 5, and what's the unit rate? 52. And then what do I do to find out how many words she types in 7 minutes? 52 times 7. And 52 times 7? 364. All right, for the next one, Prevost records how fast he can type in the chart. So now we're looking at a chart to gather our information. How fast can he type in 2 minutes? Well, first we just find out what the unit rate is, right? How do I find out their unit rate? Divide, okay? So let's just take 180 divided by 3. 60 words per minute is his unit rate. How do I find out the 2 minutes? Multiply it by 2. 60 times 2 is, so he can type 120 words in 2 minutes. Then we have Wardlow. Wardlow made a graph to record her speed. How fast can she type per minute? So you have to take the information from the graph. Okay, so the words is listed vertically and the minutes is listed horizontally. So it's words per minute. And so we have, this first point is 10 words for 2 minutes. So if she does 10 words in 2 minutes, how many is it for 1 minute? 5 for 1. So her unit rate is 5 words per minute. All right, and then we look at Johnson. Johnson made an equation to show how many words per minute is W equals 26T. So W is the amount of words, and we can find the amount of words by taking 26 times the amount of minutes, the time. Okay, so 26 is what we call our slope, which is another word for unit rate, which is another word for rate of change. So that's the amount that we're going to be multiplying by. So what is our unit rate? It's the coefficient. It's 26. She can type 26 words per minute. So how many is she going to do in 10 minutes? 26 times 10, 260. Okay, so then what the problems that you're going to be looking at are going to compare 2 and 3, maybe even 4 different scenarios. Who is the person that types the fastest word per minute? Who is fastest? Rimmer, Prevost, Wardlow, or Johnson? Fastest. It's not Rimmer. Who has the highest unit rate? Prevost, yeah. Prevost can type eight words faster than Rimmer, right? So Prevost is the fastest typist. Who's the slowest? No, slowest. Wardlow is the slowest because Wardlow types 5 words per minute. Okay? And if you were to order these least or greatest to least, you would do Prevost. Who's next? Greatest to least, fastest to slowest. Prevost, then Rimmer, then Johnson, and last is Wardlow. Yeah.